Hi everybody, today we are learning about two rules of logs and we're going to use them to make logs, like compress logs as well as expand logs. So we have our first situation. You saw this stand and talk earlier in class today, but we have log base 3 of 9 plus log base 3 of 3 is equal to 3. And we see that incidentally, log base 3 of 27 is also 3. So we're thinking, okay, there might be a situation here. See, the same thing is true here, but with subtraction, we see both of these equal 2. And then log base 2 of 9 plus log base 3 of 3 gives us this decimal, but log base 3 of 27 still equals 3. So you all broke this down a little bit for us, but basically what they're saying here is as long as we have the same base, we can multiply if there is addition. And if there is subtraction of logs, then we would divide. Like 32 divided by 8 gives us that 4 there. So we can combine these two logs into one log. Combine two logs into one log. You can only do this if the bases are the same. So you can see these are not the same. Therefore, it cannot equal the same log. So this doesn't work because the bases are not the same. So we want to make sure that we keep that note. The reason that you can think about, or like one way that I think about this is by thinking about it in relation to exponents. Logs and exponents are inverses of each other, they're opposites, but they employ the same rules. So if I have addition of my exponent, or if I have multiplication, then I have addition of my exponents, right? Like a to the eighth, right? That's similar here. If I have addition, then I have multiplication, right? It's like the opposite of it. The same way works here. If I have division, right, then I'm really doing subtraction with my exponents. Here, I have subtraction, therefore I'm doing division with my numbers here in order to combine them. So they work in the opposite directions. So these are our standard rules sort of written in math language here, right? So log base b of m plus log base b of n would give us log base b, same base, and m times n, or just mn next to each other. Right? The same is true for our natural logs. So we would have, if we had log base, or natural log of a plus natural log of b, we would have the natural log of a times b, or just 8b there. This is our addition. Our subtraction of logs, similar, log base b, our base is going to stay the same, but this time we would have m over n. Right? In some situations, you'll see the parentheses around that division bar there. And then same thing with the natural log. Natural log of a minus natural log of b is natural log of a over b. So these are the two standard rules that we're going to be working with. Addition meaning multiplication, subtraction meaning division. So we're going to do a whole bunch of examples here, but today we're going to be working with expanding, making things bigger, right? And condensing, making it smaller, or compressing. You might see it both ways. So for the blue ones, the ones that are outlined in blue, we're going to rewrite the blue logarithmic equations as multiple logarithms, right? So that'll be expanded form. And for the red ones, we're going to write each red expression as a rational number, so a number, or a single logarithm of the same base. Okay, so as one base. So let's take a look at this example here. So our problem is here. This is our log, and we're trying to expand it into multiple logs. So the first thing that I did is I said, okay, log base 3, right? So log base 3 of x, and it's being multiplied times y squared, right? So multiplication, remember? Multiplication means that we're converting it to addition. That's how we get our two pieces here, right? A second rule of logarithms is that when you have a squared or an exponent of any kind, that exponent can actually be moved out in front, right? It can be moved out in front. So we have our log base 3 of x plus 2 log base 3 of y, right? So we have our same This is our like basic rule here. So we can expand from a single logarithm here to multiple logarithms, but these are equivalent, just written in different ways, right? Later on this week, we'll find out why it might be more useful to have it in this format or in this format. So let's take a look at this one here. There are two variables, so I'm going to have two logs. I know that this is the ln of x, it's multiplication, so I'm going to use addition, and the natural log of square root of y. Remember that square root of y can be written as y to the 1/2 power, right? Y to the 1/2 power. So I'd have ln of x plus ln y to the 1/2 power. Now, the only thing that I need to move is the power here should go out in front. So I'd have 1/2 times the natural log of y plus ln of x. This would be the expanded form of this here. All right. Ooh. Hmm. Sorry about that. All right, we're back. So if we're thinking about this from here, I see that there are three letters, three variables. So I'm going to have three natural logs in my expanded form. So I would have the natural log of a, right, plus the natural log of b, since they're being multiplied. And then since this is division, I'm going to be subtracting the natural log of c squared. Right? You might already be thinking, oh, well, that is a exponent. Those exponents are coming out in front. So I'd have -2 natural log of c. Bring down ln a plus ln b. You have your expanded form of the initial equation or expression. Right? Anything that is on the bottom would be subtracted. Anything on top would be added. So we'll take another look at this one. Go to pause the video if you have a moment. But we have log of x squared, or x to the third. We're dividing by y, so subtracting log of y. We're also dividing by z. So I'm going to go ahead and do minus log z. Right? Any exponent that I have is moving out in front. So 3 times log x minus log y minus log z. This is my expanded form of this here. We have one final problem here. We have the log of the square root of all of this. So first things first, I'm going to deal with that square root by calling it a half power, something like this. One thing you could do is move the half out in front if you wanted to do that first. I personally think it's easier to just put it onto each of these variables. So I'd have log x to the 3/2, because remember it's multiplying. So 3 times 1/2 would be 3/2 over y to the 1/2, z to the 1/2. And then I have three variables. So I'm breaking it into three pieces here. Log x to the 3/2 minus, because the y is on the bottom. So log y 1/2 minus again log z 1/2. So I break it down, both of these are on the bottom, so they end up on the bottom here. Right? Just don't forget you have a bunch of exponents that are moving out to the front. So you would have 3/2 log x minus 1/2 log y minus 1/2 log z as your expanded version of this one up here. Okay. All right. So far, we've done a lot of expansion. We've taken all the different variables and we put them in their own logarithms. Now we're going to work with condensation or compressing, which means that we're going to take two logs or multiple logs and we're going to put them together. Right? So in this case, we have log base 2 of 6 plus log base 2 of 8/3, which is written here. Since it is multiplication, since it is addition, we can turn it into multiplication. Remember that addition turns into multiplication when we are condensing our logs. From there, we did 6 times 8 would be 48 over 3, simplifying 48 over 3 into 16. And then log base 2 of 16 would be 2 to the power of what gives me 16? The answer would be 4. Right, so we're able to condense all of this logarithms into a single number. Right? If we can't get it into a single number, we're going to try at least to get it into a single log. Okay, so let's look at an example here. We have 1/3 log base 3 of x minus 2 log base 3 of y. So remember that your numbers in front are really your exponents. So we have 2 and 1/3. So we have log base 3 of x to the 1/3 minus log base 3 of y squared. Right, so we have those exponents up there. I notice that log base 3, right, is the same. So I'm going to go ahead and condense those into log base 3 themselves. And I have this number minus this number. Remember, minus is actually division. So I'm going to have x to the 1/3 over y squared. You can put it in parentheses like this if you prefer. This is an excellent answer. You could also write it as the cube root of x over y squared, because 1/3 is the same as the cube root. So you could write it like this if you wanted. Cool. All right, we'll try this one. So I see 1, 2, 3 things are being added and subtracted here. So I have the natural log, and natural log. So I have the natural log of x plus 2 is being added, so really multiply times x, and then divided by x to the 3rd. So I have the natural log of x plus 2 times x over x to the 3rd, like that. Since it's written like this, I can see x over x to the 3rd. Those can be simplified, right? Take away this x, right? Remember, this would be like x over x, x, x. These will cancel, leave me with x squared on the bottom. No x's on top. So I'd have the natural log of x plus 2 over x squared. That's my final answer there. Right, so I changed it to multiplication and division, simplified it into one log, and then simplified if possible. All right. Take a moment to write this one down. I see that we have log base 3. Right. I see addition, which would mean this one is multiplied. Subtraction means this one is divided. So I'd have the log base 3 of x. I know that this 2 is going up here. So I'd have plus log base 3 of 3 squared. I know 3 squared is just 9 minus log base 3 of y. So I know this is multiplication. Log base 3, x times 9 would just be 9x divided by y. Just like that. All right. And then finally, I have this one here. So I have 1/2 going up here, 2 going up there. So natural log x to the 1/2 minus natural log y squared minus natural log z. So I would have the natural log of 1/2 minus, so that means division, y squared is going to be on the bottom, and z minus z is going to be on the bottom as well. Right? You could write it like this, or you could also put it in square root radical format, or y squared z, something like that. One thing I would note is if you had the same problem, let's say you had ln x minus ln y plus ln z, right? When you were writing it, condensing, the x is positive, so it's going to stay on top. The y is negative, so it's going to go to the bottom. But the z is positive in this case, so the z is going to stay on top. Right? So be mindful that just because they're written in this order doesn't mean that they have to be written in that order on the bottom. Right? So just a note for your notes. Okay, thanks, y'all.